everybody who is watching this fantastic video. Wonderful enough to have you today. This is Sir Olenjolai Mokota single from beautiful country that called Tanzania. I'm very happy first of all to have you today. Whether you're a national international viewer, you're warmly welcome into a beautiful online advanced secondary school that called the Tanzania Online Advanced Secondary School. So welcome once again and welcome once again. If it's your first time, it's your second time, third time, fourth time, regardless of the infinite number of times, I would like to take this opportunity to welcome you into Tanzania Online Advanced Secondary School in square bracket Olenjolai. This is an online school, so it's not a physical school. Simultaneously, because I'm teaching advanced mathematics and basic applied mathematics in the same school, I would like to welcome you into one of our global platforms of sharing these contents. Is one of our official YouTube channels, which is an online school that called Tanzania Online A-Level Secondary School in square bracket OLENJOLAIM. So after you've been welcomed somewhere, maybe the purpose of conversations, you know what will be next? You say, thank you for welcoming me. I want to listen. Why did you call me? So the next few questions, what are we doing in Tanzania Online Advanced Secondary School? Well, that's the very fantastic questions. We have an assignment or we have a vision from which has been written in our heart just to focus on 4 areas of knowledge. The first area of knowledge to teach our students on how they can extract knowledge, wisdom, and understanding from the advanced mathematics subjects and the advanced science subjects, which advanced physics and advanced chemistry, later also advanced biology, and even if God wishes, advanced agriculture and some other advanced subjects. So that's one of the focus. And the second focus, we have an assignment to teach also these students to take care of their heart, means their relationship with God, how they can extract knowledge, understanding, and wisdom from the Word of God written in the Holy Bible. And then the third part, how can we combine these 2 knowledge? Because if you want to be successful, you should be successful in your heart, in your soul, and your flesh. So the Word of God is balancing your heart and your flesh. Your heart, your soul, right? And your flesh. While this knowledge and this teaching will never help you in your heart, it will help to take care of your soul, where you have your mind and intelligence, and possibly your flesh if we be dealing with advanced biology, right? So that's what we'll be focusing. We'll be focusing extracting knowledge and wisdom from the advanced mathematics and advanced science subjects, focusing extracting knowledge and wisdom from the Word of God written in the Holy Bible, focusing on combining these 2 knowledge, and focusing on using the combinations of these 2 knowledge to solve real life problems. So 4 parts: extracting knowledge and wisdom from advanced subjects, extracting wisdom, knowledge, understanding, and wisdom from the Word of God, combining the two wisdoms, and then applying on solving real life problems. So the main objective of Tanzania Online Advanced Secondary School is not to teach students to pass the exam. However, that we might spend much of time to help you to pass your continuous assessment and your advanced certificate secondary education examination for the Tanzanians, or your high school examination. But that's not the main objective. Those are some of the specific objectives. Our main objective is to see our continuing advanced secondary school students and even graduate advanced secondary students solving real life problems. That is our main objective. Myself, I'm a product of what I'm telling you. I've been learning in my life, how can I combine the spiritual knowledge and the classroom knowledge to solve real life problems. One of the real life problems that I'm solving is this one, that possibly you are an advanced secondary student of the Form 5, whether you are pre-Form 5, you are a Form 5 students, or you are Form 6 students, or you are a high school students in any of the African countries, or in any part of the world, in any continents worldwide, in any country across the world. And then safe givens are on covering advanced physics. Why? Because it's one of the most challenging subjects, or advanced chemistry, or advanced mathematics. Possibly you are at the stage that the problems became great and great in such a way that you want to give up. I want to tell you that don't give up. Try to join and to be an active student, a serious student in Tanzania Online Advanced Secondary School. I want to promise you, if you take one session after another sessions in these online schools, you will find that you'll be transformed drastically and radically from the point where you are to the next point. So I'll let you spend a few minutes to tell you how you can join in these schools, and then we'll go into the today's session. Registration. Whenever you go to any physical high school or advanced secondary school, the first thing registration to ASO. The first thing you'll do in the first day, which you call orientation day, right? Or welcome for 5 days. Then it's registration. How will you register yourself in Tanzania Online Advanced Secondary School in square bracket Olenjolai? That's the very important question. In many schools, there are, we call it registrations in every term. Maybe at the beginning of the terms and every term you have to register yourself. The good thing of registrations into ASO, you just have to register yourself only once. There's no just in every time registrations. And just the registrations, you just need to subscribe. Then you'll be a permanent student for the rest of your life. For the YouTube platforms, but even other platforms, for example, site that we're gonna use it soon. Also, you have to subscribe. Okay, so the first thing, open what? Open what? Open an email. So have an email, in other words. The popular email is Gmail, and the other companies which provide this email is Yahoo Gmail or Yahoo Mail. The second thing, which we ask you after you have your email, then we ask you to sign in. Sign in what? In YouTube. YouTube by using your email. So you see a software buttons at the top, at the right side of the top that sign in. So click there and then enter your username and your password. Keep your password as confidential as a secret. Then the third stage now, we are after you sign in YouTube, when you are in YouTube platform, okay, or software, then search out Tanzania Online Advanced Secondary School in square bracket Olenjolai. So these are the abbreviations. Just search this name. YouTube channel Tanzania Online A-Level Secondary School in square bracket Olenjolai M. When you search, just click the buttons which will appear there, and then you're already in schools. That is more than even dealing with one video. Because right now, in this channel, we have more than 100 videos that we've already recorded and uploaded and make them public, free of charge. But we still have a vision to record more than 500 because we want to make a digital platforms or digital technology, especially the video streamings, or we like to record the active classes that we've been doing and training and impacting thousands of the students in Tanzania for almost 10 years. Myself, I did that business for almost more than 5 years. So right now I'm doing the digital platforms because I'm an electronics and telecommunication engineer. So I'm really using the knowledge and wisdom that I've been learning in one of the institutions, in one of the great institutions in Tanzania called Dar es Salaam Institute of Technology. So I'm an electronics and telecommunication engineer. So we'll be speaking about science platforms, but I will teach you later on how we can apply to solve real life problems. So after CHD to ASO, the next step, you are not yet registered. You have just reported in the school, right? So whenever there is any news, any new news, right? Any new news, you don't have any access to access them or to be informed. So now, in case there is any new news, especially the good news that we have every day, we add at least one video of advanced physics, advanced chemistry, advanced mathematics, basic applied mathematics for 5 and form 6. So you have to pray for us to make sure that we achieve this goal. Okay. So then we ask you that to click this button. The buttons which has been written are this way, subscribe. And if you look at button just below of this video, just click subscribe. Once you click subscribe, then the text will change from subscribe into subscribed. And then the icons of the bell will appear. Click these icons of the bell once, you see 3 options. Choose the option of all. When you are there, you have already registered permanently in Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM. So start enjoying. Again, that's not enough. I want to tell you good news, but if I tell you the good news, I want to ask you again, that's not enough. You want to share you want to share these information with other students across the entire country of Tanzania in all regions. You have some students who are studying Kagera, studying in Kigoma, studying in Rukwa, studying in Ruvuma. So now they can access the beauty of advanced physics, the beauty of advanced chemistry, and the beauty of advanced mathematics, and the beauty of basic applied mathematics for the rest of the year life. It's free. There's no any kinds of there's no any need now of hustling and giving up and then to say that I'm looking for the deficiency rate. No, now you can achieve your goals because the world secrets, I'm going to reveal the secret that God has been teaching me about advanced educations for more than 12 years of teaching. Stay tuned. Okay, so click share in order to share with other students. So any social media, WhatsApp, you can share this video with your friends through WhatsApp. You can share this video with your friends through Telegram. You can share this video through, with your friends through Twitter. You can share this video, the link of this video with your friends through Instagram. You can share this one through your email. You can share this video. Just if you click share there, then you see so many options of the social media and even the emails and other medias that you can share with your friends worldwide. Wonderful, that is good news for me. Again, that's not enough. In Tanzania Online Advanced Secondary School in square bracket OLENJOLAIM, we have also departments. And these departments, we categorize them in what? In playlist. And against in the playlist, we categorize them, it means we arranged our videos in different playlists. So if you are in our YouTube channel right now, just go to the playlist, you see the list of the playlist. Or just below, just scroll down, so you see the list of playlists. So if you want to focus with advanced physics for the Form 6, we have its own playlist. Okay, so one of the playlists is called Advanced Physics for the YouTube because that's one of the platforms. And then the subject is Advanced Physics. The main topic is called Electrostatics that we are going to do. We have 4 main topics in Advanced Physics Form 5. Mechanics, heat, wave, and vibrations, and electrostatics. So the topic is electric fields because I told you that, or I introduced to you that electrostatics is the main topic. There's 5 topics within it. So one of the topic is called the electric field. And this is section 13. We are going to teach about conceptual problem solving of electric fields. These contents I dedicate to pre-Form 5 or Form 5 students who are pursuing PCM, PGM, PMC, PCB. This is PCB. Only 3 combinations. PCM, PGM, and PMC, and ordinary diploma students who are pursuing different courses in science and engineering. So this I dedicate in 4 groups of students. Students who are pursuing PCM, pursuing PGM, pursuing PMC, and pursuing ODs. Okay? Yeah, PCB. Oh, forgive me. I wanted to forget the hardest combinations in the entire country of Tanzania, which is PCB. So with PCB, so 5 categories: PCM, PCB, PGM, PMC, and OD. Or ODs. PMC, it's a new combination for many students. This is physics, mathematics, computer. Wonderful. So these contents for the pre-Form 5, for the Form 5, and for the Form 6, but also dedicate these contents to the teachers who are teaching those students. They can learn, because even myself, I used to learn from other teachers. But remember, Olenjolai does not know everything about advanced physics. I just know a small portion, but have a responsibility to teach others. That's what I'm doing right now. So I'm doing my part. How about your part? Okay. So, just need to do the quick review. Let me just do the quick review of what you are going to deal with. Quick review. Okay, so we've been discussing about electric field, and its notations is this one. And we say that this is given according to the Coulomb's law, that electric field is equal to electrostatic force of attraction or repulsion over the point charge. So electrostatic force is equal to K times quantity of charge times Q of R square. So if we divide with Q, then we find that Q and Q will cancel. So we find that electric field strength is equal to constant K times quantity of charge of what? Square of the distance between the 2 charge, or between the charge and the point where we are looking at the electric field strength. But remember that we said electric field strength is a vector quantity. So we can have a vector quantity like this one, this direction. So it has both magnitude and dotting and direction. But here we're dealing with magnitude in most cases. That's why that we have the general formula for electric field strength is equal to constant times quantity of charge over r squared. Okay? This is a very important concept. But again, we taught you about the concepts of resolving, right? So, concepts of resolving. Or we say that the resultant force. Just I need to remind you about resultant force, which here we say that resultant electric field. So, resultant electric field, the formula, for this case, you say that we take the horizontal components of electric field square plus vertical components of electric field square, right? So this is the resultant electric field strength or electric field intensity. Okay, but again, you can find maybe resultant. When you say we want to find resultant electric field along x-axis, it depends the direction. If the direction is the same, then we take the horizontal components of electric field strength 1 plus electric field strength 2. Again, we say that if these are opposite, so you say you take electric field along vertical component 1 minus electric field along vertical component 2. So these are what we have been discussing. So I left the homework, which was example 24. I believe that it has been a very simple questions in session 12. So today we are in session 12, 13. We have to deal with conceptual problems of solving electric field strengths. So I won't waste much of your time. Ladies and gentlemen, let me present to you example 25. And this is a little bit up. It's not a concept yet. I think that because this is just improvements or advancement of what we taught you in the previous subtopic, which is called electric force or electrostatic force. But anyway, because you say that they are conceptual questions, so let us write answer. Let us look at today's session. So the question read or state like this. There's 2 parts. Roman A. Roman A, the question says that if a distance from a pointy charge, if a distance from a pointy charge is double, how is the field strength? How is the field strength or field intensity? Field strength. How is the field strength changed? So this is Roman A. How is the field strength changed? B. 2 polythene ball, each of mass 0.1 gram. 0.1 gram are in contact. With each other from silky thread. from silky thread. Figure 1 below. Below. Two polyethylene balls, each of the mass 0.1 grams, are in contact with each other from the silky thread. Figure 1 below. Okay. They are charged. They are charged by 2 microcoulomb. By 2 microcoulomb each of the ball. Each of the ball fly apart. In equilibrium, thread makes thread 60 degrees with each other. Calculate the electric field between the charges. Calculate electric field means electric field strength between the charged balls. Between the charged balls. So we have a figure like this. Keep enjoying the beauty of advanced physics. Okay, quadrilateral triangle. So we have 0.4 distance between 0.4 meter. And then those are the two balls. The angle between here it is 60 degree and here it is 60 degree. So if that's the case, also here it is 60 degree. So that's the question. Please copy the instruction for you to be registered permanently into ASO. Please copy it. Pause the video and copy those instructions. I believe that you have done. And I believe that you've subscribed. And congratulations for doing that. And thank you for learning with us. Okay. We have that questions, ladies. So this is figure. So for me, let me call figure 13.1. Okay. So ladies and gentlemen, let us solve the problem. We are here to solve problems. We have to learn how to solve classroom problems and then to translate the same momentum and the same mindset on solving real life problems. We should not be satisfied on solving the classroom problems. We have to think beyond that, and that's the purpose of TOASO. The purpose of TOASO is to teach our students to think beyond the classroom instruction. Right? So if a distance from a quantity charge is doubled, how is field strength changed? Solution. So solution for what? For example, 13N. So these questions is actually testing us the change of the field strength or electric field strength when the distance between the 2-point charge has been changed. So if the distance from a point charge is doubled. So let's take the first step. We can say that sketch the problem. Sketch the problem. So to sketch the problem, we have 2-point charge, right? Which have been spaced like this. So suppose that, or we have just a single point charge, and then so we want to know the electric field strength here. So distance between these 2 points, suppose that this is point A and this is point B, the distance is R. Okay? And then so you have to find out the electric field strength, possibly that being directed in this way. This is the electric field strength will be what at the point U at point B. This is case 1. This is case 1. So to find the electric field strength for that case, we say that this is equal to K times quantity of charge, which is Q, times what? Over square of the distance, R squared. So then, suppose that this is E1 and this is R1. So for the first case, the distance here is R1. The distance here is what? Is R1. Is R1. Okay. So suppose that this is equation 1. So we go for the second step. So the second step, let us sketch the second case, case 2. So case 2, we say that if a distance from a point charge is doubled. So now, this is charge Q at point A, and this one, distance has been changed to a certain point, let's say it's doubled, C, right? So the distance now between point A and point C is double, is 2R, okay? So because the distance is 2R, then we say that electric field strength 1, electric field strength 2 is equal to constant times quantity of charge Q over square of the distance, okay? So this is equation 2. So we've been asked that if the distance from the point charge is doubled, so the point charge, the distance is doubled, how is field strength? So you have to find the relationship between electric field strength in the first case and electric field strength in the second case. So here we are on the steady state. So the steady state, we say that to find the relationship between them, we say that we have to take equation 2, we divide with equation 1. So to take equation 2 divided with equation 1, this is A2 over E1. This is equal to what? Is equal to constant K times quantity of charge. And then if you square this one, we get 4R squared. We divide with electric field strength 1. So electric field strength 1, it is K times quantity of charge over what? Over R squared. So this one will make what? So we have K times quantity of charge Q is equal to 4R squared. Then we multiply with what? R squared over KQ. So K and K cancel, Q and Q cancel, R squared cancel. So if that's the case, we find that electric field strength 2 over electric field strength 1, this is equal to 1 over 4. Okay? So what is our purpose? Our purpose, we are looking at the relationship between electric field strength 2, how will it change? So if this one, the case, then we say we have to multiply by electric field 1 times what is electric field 1. So this will imply what? Electric field 2, this is equal to electric field 1. So how can we conclude? We conclude that if we double the distance from the point charge to a point, then electric field strength will be quarter of the original value. So that's what you have to compute. So the response for example 13, example 25, this is not example 13, this is example 25A. So now the conclusion, we say that the electric field strength, will be quarter of what? Of original quarter of original electric field strength. So this is what we have said, that times electric field strength 2 is equal to 1/4 times electric field 1. That's the case for example 25A. So we say the force state of what? The force state, we say that we have to check the solutions of example 25B according to the figure 13.21. I just number 13.21 according to the number of the lecture or number of the session, because this is session 13. Okay, so that will be the force state. So the force state, we have to deal with that figure, and to use this figure, the process is resolving. Okay, it's resolving. So the force state, we say that we have to resolve the electric field strength in figure 13.21. So resolve the electric field strength in figure 13.1. So to resolve the electric field strength in this figure, we have to redraw. Okay, we have to draw the figure which you've been given. Okay, so we have this figure. So we have to redraw a 2-point charge. This is quadrilateral triangle. You have to be careful when you draw it. And then the distance between them is 0.4 meter. 0.4 meter. Okay? 0.4 meter. So we have quantity of charge. So this is supposed to Q. These are identical balls. And the angle here is 60. And the angle here is 60. And the angle here is 60 degree. So we can divide this. We have to divide to get the right angle triangle. Suppose that this is O, this is point A, this is point B. So if we divide this one, we get 30 degree, and this one, we get 30 degree. Okay? 30 degree. Okay. So again, remember that here we have something called tension of the straight. And here also we have tension of the straight. So, if this is the case, this tension has two components. It has vertical component and horizontal component. Even these tensions also has two components. It has vertical component and horizontal component. So these are identical right angle triangles. Suppose that this is point C. So remember that. Triangle, right angle triangle AC, or this is equal to right angle triangle BCO. So we may use either. Okay? In our process of resolving, we may use either of these triangles. So we go for the force state. I believe that students who are pursuing PCM, PCB, and PMC, and PGM, they are really enjoying the beauty of advanced physics. So, the fifth step, we say that consider right angle triangle A, O, or ACO. Okay. So this one is the right angle. So now in dotted lines, just let us use the full lines. The angle here is 30 degrees. Then here we have tension. And then here we have a ball. Remember that this is 60 degrees. So this makes what 90 degrees, you know it. And then here we have horizontal component. So remember this, they are point charge. So we have electric field strength. So what we say, so remember, let us come back to the figure. So this is figure 13.2. So if you refer figure 13.2, when you have this horizontal component, but these are the identical charge, so it is positive Q, positive Q. So if the identical charge, there is a force of repulsion. And this force of repulsion, we call it F, which is going this way, right? And then we have again what? This is identical, so it has weight. So it means that the weight will be equal to mg. Okay? So let me do minor, because we are resolving, right? So resolve the electric fields in the figure 13.1. Okay, so let me draw like this. So if we consider that right angle triangle, then we say that here, this is the ball, right? Remember that. This is, the degree here is 30 degrees, and this one is 60 degrees. So this is tension, okay? And this is one of the horizontal component. Remember that. We said there's a force of repulsion between the two balls. And this force of repulsion is equal to F. And here we have horizontal component, which we can call the Tx. While here we have a vertical component, which we can call the Ty. But against this, the ball, so it has weight. So its weight is always towards, means that this is, suppose this is the ball, so there's a weight that acting perpendicular toward the ground. Okay? So if that's the case now, we have these horizontal components of Tx and horizontal components of electrostatic force of repulsion. But we have also vertical components, which is mg, and also you have what? You have a vertical component, which is T1. Okay, T1. So we say that the sixth state now. Okay, yes, the sixth state. Okay, but we can do it just in this state. So if now we want to know the value of Ty and Tx, we just use the trigonometrical concept. So we have to, we say that cosine of this angle, which is 30, will be adjacent, which is equal to Ty over T. So to get Ty, this is equal to tension times cosine of angle theta, which for this case is 30 degrees. For horizontal component, we say that sine of the angle, which is, because it means this is just like a line. So sine of 30 is equal to T means opposite of 30 degrees, which is Tx over tension. So the Tx is equal to tension, then you have sine of 30 degrees. Right? So now we say that this is Tx. So instead of Tx here, we have tension tension times what? Sine of 30 degrees. And here we have tension cosine of what? Cosine of 30 degrees. So we go for the sixth state. We enjoy the beauty of advanced physics in the topic of electrostatics. So the sixth state, we say that at equilibrium, horizontal force and vertical force balances. So at equilibrium, horizontal and the vertical forces balance. So if they balance, we say that F electrostatic force of repulsion is equal to tension times sine of 30 degrees. Suppose that this is question 1. Okay? I believe that you're enjoying the beauty of advanced physics and advanced electrostatic. Okay, and the beauty of electric field strength. So, if that's the one that is the equation of horizontal force. Then for the vertical component, we have Ty, which is tension times what? Cosine of 30 degrees. This is equal to what? Weight of the ball, which is mg. And this is equation 2. Right? So, the second step now, we have two equations from the resolving the forces. Second step, we say that let's now take equation 1 divided by equation 2. Okay, so equation 1 divided by equation 2. So T sine of 30 degrees over T cosine of 30 degrees. This is equal to what? That is equal to the electrostatic force over weight mg. Right? So then tension and tension cancel. So this will make tan of 30 degrees is equal to electrostatic force over mg. This is equation 2. Right? So if that's the case, you say that also from the fact that electric field strength is equal to force over quantity of charge Q. To be given, but what is force? Force is constant K times quantity of charge times Q over Q times R squared. So Q and Q will cancel. So simply, electric field strength is equal to what? But before even we just clarify this, clarify like that. So electric field strength times Q is equal to force. So this is equation 4. So now we say that substitute. This is a step. Substitute equation 8, 4 into equation 3. So to substitute, we say that tan of what? Of 30 degrees. This is equal to what? F, which is quantity of charge times electric field of what? Over mg. Is it clear? Yeah. Okay. So now we have a question which states like tan of 30 degrees is equal to quantity of charge times electric field strength of a weight of the ball, which is mg. So make it the subject. So to make it the subject, we have 1 with cross multiplication. Then we say we have electric field strength is equal to mg tangent of what? Of 30 degrees over Q. So mg tan of 30 over Q. That's the electric field strength. Okay. So if that's the case, now we can find the electric field strength. How? So this will be the 9th step to compute electric field strength. So this is equal to the weight of the ball is what? It's 0.1 gram. So mass it is 0.1 times gravity, which is 9.8, and hence times tangent of 30 degree over quantity of charge, which is Q, will be given so 2 microcoulomb. So 2 microcoulomb is 2 exponent negative 6. So electric field strength, which will be in Newton, so the unit here will be Newton per coulomb. Okay? So just use your scientific calculator, and the good news that we have it in Tanzania Online Advanced Library. So it is 2.83 exponent negative exponent 3 Newton per coulomb. So the question was asking us electric field strength. So therefore, we say that the electric field between two balls is 2.83 exponent 3 Newton per coulomb. Okay. That's the response, and at the end of that, the end of the solutions of that problem. So let us go to example 26, which also is conceptual. Example 26, ladies and gentlemen, get prepared to receive example 26, which is a little bit a trick question compared to other questions. Because it's involving also resolving. So this entire session is all about resolving. It's all about using the concept we taught you in mechanics in dealing with problems of electrostatics. So example 26, calculate the electric field. Calculate the electric field intensity. Electric field intensity at A, B, C, so let me draw the triangle first. Is the triangle. So this is point C, and this is point Y. PQ, and this is 2. So this is 10.8 coulomb, and this is 10, it's from negative 8 coulombs or microcoulombs, you need to coulomb. Positive 10.8 microcoulomb and negative 10.8 microcoulomb. So 10 exponent 8. Distance, this is electrical triangle. So the distance here is 0.1 meter, and this one is 0.1 meter, and point A is at this midpoint, Here you have 20b. And also the distance from B to P, it is 0.05. 0.05 meter. 0.05 meter. And this one is 0.1 meter. 0.1 meter, 0.1 meter, 0.1 meter. Q, so 0.1 meter, 0.1 meter, 0.1 meter, A, and then Q, that's point B. This is not like a coulomb, this is coulomb. Excuse me, this is coulomb. Is it 4 coulomb? Let me check. Yeah, it is coulomb. So, have calculated electric field intensity at point A, at point B, at point C. So this is what? Figure 13.3. 13.4, because you have 3 figures already. So ladies and gentlemen, let us work hard. For that problems, we have to work hard, especially for the point C. Because the point C will be experiencing the horizontal components of force and vertical components of force. While point A and B, they won't experience such kind of challenge. So, solution. Solution. So the first step, we say that find electric field strength at point A due to charge P due to 10 exponent 8 coulomb. So from electric field strength is equal to constant K times quantity of charge Q over R squared. So it's electric field strength at point A due to point charge. Due to point charge at P is equal to constant, which is 9 exponent 9 times quantity of charge, which is 10 power negative 8 coulomb over square of the distance. What the distance, this is 0.1. What the distance from here to here is 0.05 meter, and the distance from A to B is 0.01 meter. No, 5 meter. So because point A is midway of 0.1. Remember that this is quadrilateral triangle. Remember, so the angles can be determined from that. So the distance between this point charge, the distance between point A and point P is 0.05 meter squared, or the form. So it says that the electric field strength that point A will experience due to point charge at P. So you have to use your scientific calculator just to compute. You get 3.60 exponent 3.60 exponent what? Exponent 4 Newton per coulomb. 4 Newton per coulomb. How do you compute? You just have to take you have to take 9 exponent 9, then you multiply with what? Multiply with 10 power negative 8 over what? Over 0.05 square. 0.0, so over 0.05 square. Answer is 3.6 exponent 4 Newton per coulomb. Then let us find, that will be the second thing. Let us find the electric field strength at point A due to point charge Q. So due to negative 10 exponent negative 8 coulomb. So to find it, so electric field strength at point A due to point charge Q is equal to K, which is 9 exponent 9 times what? We don't use the negative sign, so it's negative times 10 exponent power negative 8. Then the distance between point A and point Q is 0.05 square. So the response will be the same, 3.6 exponent 4 Newton per coulomb. Then let us check direction. Suppose that here we have a point charge Q of 1 coulomb, 1 exponent of what? So suppose that here we have a point charge of 1 exponent negative 9, negative 8 coulomb. So suppose that here we have a positive point charge. Always we use a positive point charge. So it means this point charge will be pushed, it means will be repelled by 10 exponent 8 coulomb. While this, so it will be repelled. So if it will be repelled, the force here will be in this direction. Right? This is force at point A due to P. Then positive Q and negative 10 power negative 8 is an opposite charge, so they will be attracted. So this point will be attracted towards this direction. So here we have force of A due to Q. Right? So this one we say that this is along or towards what? So we say that this force will be towards Q. And this one we say that will be towards what? Towards Q. Right? So it means that if now we have this here, so this is point P. So this is what? So this is point P, this is point Q. PQ. Then here we have a point. This is point A. So the direction of the force, this is force at point A due to P, and also these the directions because force of attraction is force of repulsion, force of attraction, and force of attraction here. This point will be attracted due to Q. So same direction. So you say that the steady state, the electric field strength at A is equal to summation, right? Summations of electric field strength at A due to P and electric field strength at A due to P. So because they have the same value, so simply this is equal to 2 electric field strengths at point A due to P. So you say electric field strengths at A is equal to twice times electric field strengths due to AP, so it is 3.6 exponent what? Exponent 4 Newton per coulomb. So that will be 7.2. So therefore, electric field strength, electric field intensity, electric field intensity at point A is 7.2 exponent what? Exponent 4 Newton per coulomb. So we have answered the first part of the questions instead of 3 parts. While you are still copying and you are still thinking about the next point, I would like also to share with you about good news, because for me, I always have good news. And the good news is when we are establishing these online advanced secondary schools, okay, we use the platforms to teach, but we are not satisfied only to teach our students about what we have prepared for them. We like also teach our students on how they can use reference materials such as textbooks and reference questions and answers books for them to go further, because we cannot teach you everything. We just have to give you the concept and simplify it and arrange our every concept from the simplified stage to the intermediate stage to the complex stage. Like now, in case of this session of elective field strengths, this is not a begin. It means that for the beginning of elective field strengths, this is the next session. I built it on top of another session, which is session 12 and even session 11 and session 10. All of them, they're still focusing to teach you about elective field strengths. So you have to take them sequentially. So we have we have Tanzania Online Advanced Library, where we have so many materials to equip our students. We are not doing business, actually, we are equipping our students. So we are providing service, remember that. So one of the items is a original scientific calculator. You can order them. We are just selling a buying cost, okay, buying price that we used to buy in the local shops. So as advanced students, you should have a scientific calculator, and especially the original ones, because you'll use it, and even later on, during your undergraduate studies, you might need a scientific calculator. So you can order this scientific calculator. This is Casio Function 991 original. We have them, and we can send in any schools, or we can send anywhere in all 31 regions of Tanzania right now. Again, we have a original book of the syllabus book that titled as Physics Syllabus for Advanced Secondary Education for 5046 for Tanzanian secondary high school student. You can order this book, just go to the descriptions, just click the buttons here. You see it has been written show more. So show more, just click these buttons for you to just in YouTube, okay, for you to get descriptions and to see the link. So you can order it, we can ship in all 31 regions. Wonderful. Some of the physics reference books are big, actually, and a real challenge. Even myself, when I met with these books for the first time, this is just one book. You have to start almost 5 books of this size. So I was kind of panicking, but I thank God He has given me peace and tricks and techniques. I made mistakes because I used to learn from mistakes. I made mistake on reading this book. I thought that I should read the entire book. So I was reading everything. But the strategy here, one of the strategies means how you can use the syllabus and physics syllabus for advanced secondary education, so advanced physics syllabus for advanced secondary educations, to extract the important information from this book. So I will teach you. So don't worry. But you can order this book. This is called the Principles of Physics, or SG and the Principles of Physics, and writers are Mehta family, and this is for class 11s in India. The authors are Indians, right? I'm believing that the advanced physics books for the Tanzanians, such as the ones which has been written by Unga, yeah, are still coming. Or yes, there are some of the physics teachers who are still writing books right now for advanced education. So you may have this, you may order these books. This is just a sample book. We have so many reference advanced physics books. We are selling them in a very reasonable price in order to equip our students with materials that they have to make sure that they are going through them. So you will need these books in referencing. So you need at least 5 books of the 5 reference books. Again, we have another questions and answer book, which is called the Advanced Physics 1 Review, which comprises Advanced Certificate Secondary Education Examinations question from 2003 to through 2013. You can order this book and we can send in any 31 regions. Again, we have another sample, Advanced Physics 2 Review book. Questions and solutions from 2006 through 2020. Through 2020, means 2020, okay? So these are another reference books that we'll be using effectively, especially with electrostatics. We'll be using this book effectively in our sessions. So you can order it and we can send in any 31 regions of Tanzania, including Unguja and Pemba. Okay, so now let us continue some questions. We still have a problem there, right? But this is the classroom problems. We have to change it into the real life problems. So we have to calculate electric field strength intensity at A, B. So we are done with A, we have to go for B, B at this point. So we have to follow the first step. The first step, we say that sketch the problem. So to sketch the problem, we'll be focusing on the information that we want. We have a straight line here. This is 20B. And suppose that this is 20P. So the 20P, we have 10 exponent negative 8 coulomb. The distance here, it is what? 0.05 meter. While the distance here, it is 0.1 meter up to up to another point, which is point here, where we have what? Negative 10 power negative 8 coulomb. So you have to find the electric field strength we are going to be. One, first of all, we can know the direction. Suppose that here we have 1 power negative 8. So we have a positive 1 power negative 8 coulomb. So this is the positive charge. So this B point B will be repelled by dot. This is electric field strength at B due to P. And then here we have negative and positive. So this one will be attracted. Is it? Will be attracted. Is that positive? So that will be, yeah, will be attracted. Will be attracted. Okay. Because this is positive, so yeah. So this one will be attracted by E. 20B due to Q. That's the direction of the force. Okay. Wonderful. So don't worry about that. That's the directions of the force. So sketch the problem and show direction of what? Of electric field strength. So we'll show. So after sketching, we go for the first step. The first step say that you have to find what? You have to find electric field strength at point B due to P. How? So remember the formula. So A at B due to P, we say it is K, which is 9 exponent 9 times what? Quantity of charge, which is 10, so negative 8 coulomb of what? The distance between B and P, it is 0.05 meter, so you square. Use your scientific calculator, compute it. So we have 9 exponent 9 over 0.05 square, so power times 10 exponent negative 8. So this again is the same response. It is 3.6 exponent 4 Newton per coulomb. But this is towards what? Towards B. Then you have electric field strength at point B to the point charge Q. So this is 9 exponent 9 times 10 power negative 8. So now the distance is 0.05 plus 0.1. So here we have 0.15 square. Okay. So we have what? We have 0.15. Then we have to square. Then we have 9 exponent 9. Then multiply by 10 power negative 8. So the answer is 4 exponent 4 Newton coulomb. So what the direction of the force? The direction of the force is upwards. So let me leave that question because we still need to divide. So if you didn't finish to copy, you can play back this video and see where we end. Okay, so you have two forces, EBP, so you say that this is the 6th state. Say that EBP is opposite to EBQ. EBQ. EBP is opposed to EBQ. So, if that's the case, we say that E and B is that because they are in opposite direction, right? Then we say that this might be EBQ minus, because this is the larger force, minus EBP. So resultant force at point B, this is equal to what? Is equal to 4 exponent 4 minus 3.6 exponent 4 Newton Coulomb. So therefore, electric field strength, or electric field strength, selective field intensity at B is 4.3 Newton per Coulomb. Imagine. Remember to order the reference books for advanced physics and reference books for advanced chemistry and reference books for advanced mathematics. That will use them during your advanced journey of learning in our Tanzania online advanced library. Excuse me, this is 4 power 3. 4 power 3. If you check your scientific calculator, yes, 4 exponent 3. 4 exponent 3. So if you 4 exponent 3, so we say that this we have to reverse to avoid negativity. So this we should subtract because this is a small value. It's only 4,000, while this is 36,000. So if we do that, we'll end on having 36,000 minus 4,000 is equal to 3.2 exponent 20 exponent 4. Exponent 4. So this is the electric field strength at point B. Okay. Then we have to deal with point C right now. Mostly challenging part. But we have to deal with it. It's the problems that we have to solve. We are born to solve problems and not create problems. We can create a problem for somebody also to enjoy life, right? Or somebody to solve in order to live. Okay. So the 60th state, we have to find electric field strength. How to find the electric field strength at point C. So to find electric field strength at point C, we have to be careful. Okay? We have to be careful. So let's feel that in point C, we have the two effects. So let us come to this figure. So we say that consider figure 13.20. So this is figure 13.4 to 13.5 below. So let me draw this figure here. And I draw just the part that we need to deal with C. So we'll be given equilateral triangle. Here it is 0.1 meter. Here it is 0.1 meter. Here it is 0.1 meter. Here we have a point charge at point P. Here we have point Q. Here we have point C. Okay? So this is positive 10 exponent negative 8 coulomb. This is negative 10 exponent 8 coulomb. Okay? Wow. So then we say that if this is a quadratic triangle, here we have 60 degrees, and here we have 60 degrees. And even here also we have 60 degrees. So we can have a rectangle triangle. We can also check the direction. Suppose that here we have 1 power negative 8 coulomb, positive. So the point charge at C will be repelled. So this one will be electric field strength at C due to B. And also, if you check this one, means the point charge at C will be attracted. This will be electric field strength at what? At C due to Q. Due to Q. Okay. So if that's the case, okay. So we are expecting to have what? Horizontal component and vertical component. So let us have a horizontal line like this. Then let us have another vertical line like this. And then if we draw this, we have this one. So the angle here will be what? So these are the directions of the force. The angle here will be 60 degrees. And also similarly, so the angle here will be 60 degrees. Okay? So if you examine now, we are going to have horizontal force. So this will be, yes, electric field strength. So means for horizontal component will be in this system. ECP X and also ECQ X will be on the same direction. So we are going to add them. The vertical component, we say that here we have what? ECP 1 downwards. And here we have what? ECQ 1. So they are opposite. So we have to subtract. So this is figure 13.5. In short, figure 13.5. So that is resolving. You can pause this video and try these questions on your own. It doesn't mean that maybe you should be very intelligent to solve these problems. You just have to follow the principles of electrostatics. And the common principle is Coulomb's law. And like charge repel and like charge attracts. That's the principle, the fundamental law of electrostatics that state that the like charge repel and unlike charge attract each other. That's the one that we are using to know the directions of the forces. And then the general formula of electric field strength we use to deduce from Coulomb's law of electrostatics. Wonderful. So those laws are very important. Okay. So if this is the case now, if this is the case, so we have to go. So we go for the 7th step. Now life is a little bit simplified. So the 7th step, we say that let us find what? How about distance? Distance between them is defined, 0.1, 0.1. Should not lose ourselves. So let us find electric field strength of C due to Q, X, and electric field strength or electric field intensity at C due to P, X. Okay, let us find the horizontal component. So in this one, we are going to get the same value. So not mistaken. They are equal values. They are equal. So ECP horizontally and vertically, they are equal. So this one is equal to ECP x, and this is equal to K, which is 9 exponent 9 times 10 exponent negative 8 over the distance, which is 0.1 squared. Answer of the answer is what? The answer is 9 exponent 3 Newton Coulomb. 9 exponent 3 Newton Coulomb. Okay. So they have the same. So again, if you resolve, we say that now so if that's the case, say that ECQ resultant, right, or summation of ECQX, this will be equal to, because these are the two equal forces. E twice of what? ECQX, but remember that this is horizontal component, so it means that if we prolong the rectangle triangle here, so cos means that cosine of this angle, cosine of 60, so we find that cosine of 60 for this case is equal to ECPX over what? Over ECP. Right? So ECP. So it means this is, so if you make ECPX the sum, then we are going to have ECQ or ECP cosine of 60 degrees. So remember that this is what you call ECQ. Okay? So if that's the case, we say that now EC along x-axis resultant is equal to 2 times 9 exponent 3 times cosine of 60, which will give us what? Cosine of 60 is equal to a half. So a half times 2 times 9 exponent 3 means this will make what? So copy this before I clean. Stop the video, copy that. And yes, I want just to leave the question there to remind you and to encourage you that you can solve those problems. And these are the most often questions asked in the exam. Okay. Okay, so you say that now the resultant electric field strength at C along x-axis, this is equal to 9 exponent 3 Newton Coulomb. Newton power, Newton Coulomb. So that is resultant field strength. So you say that electric field strength, electric field intensity, is 9 exponent 3 Newton Coulomb. Okay. Now, at this this is horizontal component. We have to find a vertical component. Excuse me. Okay. So you go for the 8th step. The 8th step, let us find what? Let us find electric field strength of CP along Y and electric field strength at C due to point charge at Q along Y. So if you find these are the opposite, right? So you see that resultant, so also these are equal, you can find them. So electric field strength, because of the same distance, electric field strength at C into Y, this is equal to what? Is equal because they are equal forces. So you can say that this is okay. So let's say ECP1. So this is equal to ECQ1. This is equal to K, which is 9 exponent what? 9 times 10 exponent negative 8 over 0.1 squared. So simply you'll find that ECPY, one of them, because they are equal, is 9 exponent 3 Newton. To find resultant what? Vertical component of electric field intensity along one. This because ECQ is toward down, and then ECQ is toward C. It's away C. This is away C also. It's a downward force, downward electric field intensity, upward electric field intensity. So you have to take either electric field intensity at 20p minus electric field intensity what? Point C with the point charge Q1. So because these are the equal forces, so this means that resultant electric field strength at C due to Y is equal to 9 exponential. Because for this case, we say it is twice. Twice because the angle is 60. Okay? So the vertical component here will be sine of 60 is equal to what? Is equal to ECQ1 over ECQ. So if that's the case, we say that for this case, you say that it will be ECQY sine of 60, yeah, 60, minus what? ECPY sine of what? Of 60. So if you find that electric field strength at C due to Y, this is equal to 0. So the resultant force in vertical component is equal to 0. So if it is equal to 0, then now we have to find the resultant for electric field intensity at point C. So the 9th step, which is the last step, resultant field strength. Resultant field strength at what? Resultant field strength at C is what? Is equal to the square root of resultant field of electric field intensity at C along x square plus what? Plus summation of the resultant electric field at C due to y squared. So this will give us the resultant field at point C. So for this case, this one is 9 exponent 3 square plus this one is 0 square. So electric field strength at C, this is equal to 9 exponent 3 Newton per coulomb. Wonderful. Yeah, that's the response. So therefore, thank God for that. Electric field strength at C is 9 exponent 3 Newton per coulomb. That's the response. Okay, we have just done 2 questions. I seem like you are so exhausted. You, not me. But let me leave the homework for you. It's enough. This you have to meditate and redo these 2 questions several times as well as we can. So now it's your homework. Let me challenge you. And we'll continue the next session. Let me give you another challenging problem. This is example 27. Homework. This is homework 13. Example 27. Square A, B, C, D is the name of the figure. Having each side, these questions are commonly in Chandi 2. Having each side 4 centimeters. Find electric field strength. Find the electric field strength. Strength at D. Assume the median is L. That's the assumption, that's the common assumption. So square ABCD having each side 4 centimeters, find the electric field strength at D. So we draw that square. One, two, three, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait a moment. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You just have to draw the square. So this is D. Here it is 4 centimeters. 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 So we have first point A. 8 exponent -9. This is point A. Point A. Its charge is 8 exponent negative 9 coulomb, 8 exponent negative 9 coulomb. The other one is positive 32 exponent negative 9. This is positive. So this is going to be, this charge is positive 2 negative 9 coulomb. And this one is positive. This is point C. This is positive 24. It's point negative 9 coulomb. So this is figured. This is figure 13.5 and 6 if I'm not mistaken, 6 or 7, something like that. Okay, so that's the homework for you, because we are teaching by using, we are focusing on competence-based, that the first thing according to the syllabus. But again, this is a student-based or student-centered course. So we are leaving so many homeworks for you to try, and then we do corrections as well as possible, especially for those challenging concepts. So make sure to do example 27 and submit your solutions in the comment section. Or just you can go and, I mean that later on so I'll share it, or you can just send your solution, because you have to draw and even writing some of the computation. You can send your solutions and you can email me with questions through this email. So you send homework, that homework through Olenjolai, Moko. I think that I want the good space for you to read. So send homework. Send homework at my 13 at this email. Olenjolai. Anyway, just send it at comment section. Comment section. Okay. Okay, ladies and gentlemen, this is the end of session 13 of electrostatics in the subtopic, or in the topic called the electric field strengths. So I've been teaching about conceptual problem solving on electric field strengths. I thank you very much for joining me. I believe that you will watch this video several times as well as you can, so that these concepts will be built in your mind for the rest of your life. Don't forget to subscribe. Don't forget to share these contents. Don't forget to read the descriptions. Don't forget to visit the Tanzania Online Advanced Secondary Library. Don't forget also to join me in the next session, which is session 14. I invite you right now, and subscribe for you to get notifications when we add any new video. Keep on enjoying the beauty of advanced physics in Tanzania Online Advanced Secondary School. This is a national teacher. My name is Olenjolai. I love you so much, and may God bless you and keep you until we meet in the next session. Enjoy the beauty of advanced.